Okay, so 3.4 is about equivalent statements, and if you have multiple statements and you find their truth, like value, answer column, and they are exactly the same, then we would say that they are equivalent. I didn't actually write that here. Yeah, I'm lazy, but we're gonna go and add here, like, therefore, these statements are, and then do your equal sign with your 3 bars. That's like you just kind of declaring, like, okay, yes, did the work, they are logically equivalent. Okay. So, what we're going to do is the same type of work, but we're only going to look at P's and Q's, excuse me, and it's sentences. So, that's what makes this next example different for sure, is going to be the fact that it's going to be all in sentences. So second example, it says, what is logically equivalent to, quote, it is not true that the tire is both out of balance and flat. End quote. So what is logically equivalent to this? It is not true that the tire is both out of balance and flat. Okay, so that technically is what we're going to call like our original statement, okay, because it is the statement that they gave us first. Now, they're going to show us A, B, C, and D statements. And it's just all these different examples in sentence form. After that, we'll declare a P and a Q, and then we'll do a truth table for all of them, and then we'll see which ones have the same answer column. Okay, so same exact thing we just did, but it's only P and Q. And we're looking at sentences. Okay, so for our A statement, what we have is if the tire is not flat, comma, then the tire is not out of balance, period. Okay, our B statement is the tire is not out of balance or the tire is not flat. So the tire is not out of balance or the tire is not flat. C, the tire is not flat. And the tire is not out of balance. I don't know why I squared A, B, and C, and then all of a sudden I just circled D, but I'd probably, I don't know why I did that. Okay, if the tire is not out of balance, comma, then the tire is not flat. When I was writing this, I noticed, I was like, man, in my A, B, C, and D, I mean, even in my original statement, like I've got a bunch of nots, right? Not. Okay, so here's the solution. Here's how you work on this. The first thing that you would do is we need to declare, we need to state, we need to make our P statement, we need to make our Q statement. And then there's like a hint here or something that, I need y'all to do, which is negate your, I'm so sorry, why'd I say that? Omit your negations. So when I make a simple statement P, I'm not going to include the word not. Right? I'm going to take that out. Omit any negations. Whenever, what? I said negations. Whenever I make my simple statement Q, I'm going to omit any negations there. So we're going to let P be the simple statement, and then I look at my original. Okay. It says it is not true that, okay, that's a tilde, right? That's a negation symbol. I don't want that right now. I want the statements, the simple statements. The tire is both out of balance and flat. So here it's kind of negating both of them in a way. The first thing that I see is the tire is out of balance. Okay, that's my P. I'm going to let P be the tire is out of balance. I'm going to let Q be the simple statement. The tire, now it talks about it being flat, right? So the tire is flat. And even though there was like the word not in the original, whenever you make a P and you make a Q, don't include those nots, okay? So omit your negations whenever you kind of declare these simple statements. I just bit my tongue. It's like the fourth time I bit it in a week. Okay, so what was the original? My original, it is not true that, and then it has the operation of the conjunction. So the fact that it says it is not true that, then it shows that the tire is both out of balance and flat. So the tire is out of balance and the tire is flat. That is saying it is not true that the tire is both out of balance and flat. Okay? We need to write our A, our B, our C, and our D. And then when I change pages, we're going to do a truth table, and we're going to see which one of these purple statements here is equivalent to the original one. Like logically equivalent, like they're saying the same thing. Okay, so what is our A statement? I'm trying to go back to my squares. It says, if the tire is not flat, then. Y'all, those are my keywords right here. If, then. Okay, I see the if, I see the then. Immediately I know that's my if-then conditional one-sided arrow. Okay, the antecedent is the one that comes before the arrow. Okay, and it's smushed, it's sandwiched in between the if and the then. So it's this right here. The tire is not flat. This is my Q statement, but I notice that there's a negation, right? So Q, but negated, and it's the antecedent, it's smushed in between, so it comes first. After the word then is what follows after your arrow. It's called the consequent, remember? So after the word then, I have the tire is not out of balance. That is my P statement, and it's been negated. Okay? Now let's go and write symbolically what our B is. Our B says the tire is not out of balance, or the tire is not flat. or. That's my operation, right? Or, that's that V. To the left of the word or, obviously, would be what would come first, right? It says the tire it's been negated, not out of balance, okay? The tire being out of balance is P. Not being out of balance would be not P. After the word or, it says the tire is not flat. The tire being flat is Q. If I negate it, it's not Q. See? Okay. For C, I have the tire is not flat and the tire is not out of balance. So I see the word and, which is my conjunction. Before it, I have the tire is not flat. So that would be not Q. And the tire is not out of balance, which is not P. For D, I have if the tire is not out of balance, then the tire is not flat. So if, then is what tells me symbolically to do a conditional arrow. It says before the then, right, like kind of sandwiched in between, called the antecedent, it is the tire is not out of balance. So before the arrow, I would have a not P. And then after the arrow, after the then, it says the tire is not flat, which would be a not Q. I technically have 5 different statements here. I have the original and statement A, B, C, and D. On the next page, I'm going to do a truth table, and I'm going to do the actual work needed for all of these, and one of these is going to be logically equivalent to this statement right here. And it's actually what points out something really important in this class. I believe that's page 2. So hopefully y'all haven't had to switch yet, so you can kind of keep your eyes on this. But I am going to move my page. Okay, so what we're going to do is truth tables for all 5 statements. That's just kind of what I have written up top. Truth table for all 5 statements. And what we're doing is we're looking for logical equivalence. So we're looking for something that has the same answer column. Okay, amazing, fun, great thing that it is only a PQ. And if you notice, we negated a whole bunch, right? So it's going to kind of be the same work each time. The only thing that's really different is going to be that the symbol in the middle. Okay, so true, true, false, false. True, false. True, false. So what I'm going to do is I'm going to list the original, not list, but like write down the original statement, which was, it is not true that both P and Q, right? That was like the original. Then we'll have A, which was not Q, then not P. Then we have our B statement, not P or not Q. C statement, not Q and not P. And then D statement, which is not P, then not Q. There's a lot of 1, 2, 3 work in here, but it's okay because you're just kind of writing the same thing over and over again. If I do the original, I need to work inside of those parentheses first, and then I would negate it. So this is what I would do first, and then that's going to be the answer column. This is just a simple conjunction, P and Q. So and is both. So this and this, yes. This and this, no. 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 Now, negate. That is actually the answer column for the original. I'm looking for another FTTT, right? And then I have the equivalent statement to it. Okay, so if you notice here, it actually has me negate Q, then I need to negate P, then I would do the conditional. So the negation of Q, if Q is TFTF, this answer column is FTFT. The negation of P would be FFTT. The third and last step for statement A would be the if-then. This is only false when you start with T and you go to F. Everything else is true. This is the answer column for that this statement, and it does not match the original, so this one is not the one that's equivalent to it. Move on to the next one. Negate P, then Q, then take the disjunction. And that's what I mean, a whole bunch of negations. We're kind of repeating ourselves on all these negations, y'all. Negation of P is FFTT. Negation of Q, FT, FT. And then we take the or. This or this T, no. This or this, yes, yes, yes. Answer column is FTTT. You see how those match? Whenever I did this, I was like, okay, those match, I'm done. I'm gonna go ahead and do the other two, but this one is the one that ends up being equivalent to your original. So I need to negate Q, negate P, take the conjunction. On D statement, the last statement, I'll negate P, negate Q, take the conditional. So I have FT, FT, FFTT, FFFT, this one, the last one, is FFTT, FT, FT, T, T, F, T. So what we end up seeing and what we can conclude is therefore that original statement that we had is logically equivalent to, I think it's B. Anyone notice something that's written on the back of the wall that matches this? All right, so this is actually an example of De Morgan's Law. So whenever you're seeing these, you're like, I have no idea what that means. And I just wrote the exact same thing again. And technically, this was an example of showing you that even though these might not look at all similar, when you do the operations that are needed in this order, you end up getting equivalent statements. Okay, so we're going to kind of go ahead and write down the De Morgan's laws for logic. I did write here, this is an example. That was an example of De Morgan's Law. Okay, so, and here's De Morgan's Law. De Morgan's laws of logic for any two statements, P and Q. So the first law we have is if you have the negation of two simple statements conjunction, it is logically equivalent to the disjunction of their negations. And then similarly, if you have the negation of two simple statements disjunction, it is logically equivalent to the conjunction of their negations. Definitely not technical, but it's almost like that tilde, that negation, was kind of distributed to the inside, and then that operation had been flipped. Mathematically speaking, if there is an operation, you can't distribute, but just talking about the way that it looks, right? It does look like this negation was kind of given to both of these statements. And then if it was a disjunction, it became a conjunction. If it was a conjunction, it became a disjunction. Okay. If you wanted to, you could have your, you could like do a truth table for like this bottom one, this second law, and then a truth table for this, and you would notice that they would be the same if you needed to. We're not going to do it, but if you needed to, you could. Okay, so we need to talk a little bit more about our conditional statements. There's actually a lot of different variations and different ways that you can write conditional statements. These first two right here, I didn't really know that much about until this semester. The last three are like really important, like you'll use them a lot. I just made sure to include these two because I'm not for sure what your homework says or does, and I want to make sure you can answer all your problems. There's a way to write a conditional statement as a disjunction and then be equivalent, okay? So the conditional statement as a disjunction. And this is how you do it. The first thing you do is you negate the antecedent. The second thing you do is you change your conditional symbol to obviously a disjunction symbol because I'm going to write the conditional as a disjunction. And then you keep the consequent. I just wrote keep consequent same. Grammatically, you could write like keep the consequent the same or keep it the same, but keep same. Negate the antecedent, change your symbol, keep the consequent the same. And this is what that looks like. A conditional statement, y'all, it's up here. It's like fifth column, 4, 5, 6, sixth column, right? That's if P, then Q. This is a conditional statement. Well, there is a way to write this statement as a disjunction and them end up being the exact same thing, like they're equivalent to each other. And what did it say? Negate the antecedent. The antecedent is the one that comes first. That is our P. Negate the antecedent, change the conditional to a disjunction, keep the consequent the same. Okay, those are equivalent statements. Okay, and then we have the negation of a conditional statement written as a conjunction. So it's kind of a little bit wordier there. The negation of a conditional statement written as a conjunction. What we do here is very like kind of, it's the same difference of the previous steps. So here we negate the consequent. change our conditional symbol to a conjunction, keep antecedent same. Okay, so the conditional statement is if P then Q. This says the negation of a conditional statement. So that's putting your tilde on the outside. And this is telling me that if I take these steps, I actually have an equivalent statement, and it is the negate the consequent. So the consequent is the second one. If I negate that, change my symbol to a conjunction, and then keep the antecedent the same. Okay, P is your antecedent, Q is your consequent. Yes, it's originally starting with the tilde or the negation, but that doesn't really have anything to do over here. The only thing that is your antecedent is your P, and I say keep that the same. So P. The cool thing, I don't know why these don't have like names or whatever, but I mean, if you did do these often enough and you learned that they were equivalent to each other and you're asked if something's equivalent and you notice this pattern, you can be like, oh yeah, like there's no reason to do a truth value. Trust me, I know that this is the conditional statement written as as a disjunction. Or you could say, hey, not going to do the truth table. I know this is De Morgan's. I know it for a fact. Kind of get out of doing that work. Moving forward, if you ever see that. Yeah, it's really not thinking. Yeah, I would put an asterisk next to these. Asterisk. Not these we just did, but the ones we're fixing to do. Sorry, kind of paused there for a second. These are important. Like I said, I'd never even seen these. Like, at least not in depth to where I knew what steps to follow and I knew that they even really existed. Maybe I would just do all the truth tables and I'd be like, oh, hey, they're the same. I never noticed a pattern. It was like I could always just kind of state that I knew it was the same before doing the work. These are the variations of conditional statements. Okay, so go and write that, variations of conditional statements. And I really like these, so I would make sure that you really know these, okay? I said variations of conditional statements. Y'all, I wrote conditional variations because I'm lazy and I flipped those two words, and that's what allowed me to not have to put all those other words. So conditional variations. Obviously, we're talking about conditional statements. That's why I guess I didn't do it. I didn't write it. And then this is the variations of the aforementioned statements. Okay, so when I talk about conditional statements, every single time I've ever talked about a conditional statement, this is what I'm talking about. Right there. That's a conditional statement. Right? That's how all those other examples started before we showed what it was equivalent to. If P, then Q. That's a conditional statement. I'm going to kind of read what it said, how you read it. So if P, then Q. That is a conditional statement. Okay? Now the different variations of a conditional statement are, let me do this. I really want to use this black marker, but I don't really want it to bleed through and mess up these other pages. Okay, so the first variation of conditional statements that we have is a Converse. Okay, and the converse of a conditional statement, you do if Q, then P. If you look at what we did there, we took the Q and the P and we like swapped them, right? And so like the work for a converse is to swap the antecedent and consequent. Okay. The second variation of a conditional statement is called an inverse. And it is not P, then not Q. And if you look at that one, what did we do there? We look at the conditional. The conditional is if P, then Q. For the inverse, I said if P, okay, so that stayed in the same like location, but it was negated. Then Q, okay, Q obviously also stayed in the same like position or whatever, but it's been negated. And so what we did here was we just negate antecedent and consequent. So far, converses we're swapping them. Inverse is we negate both of them. And then the last variation that we have for conditional statements, this one is called a contrapositive. And this one goes not Q, then not P. If not Q, then not P. You look at the original, what did I do? Okay, it looks like Q and P was swapped, and they both were also negated. So swap and negate. Antecedent and consequent. Okay, y'all. I have a P and a Q statement. We'll write it the way it's supposed to be written as a conditional. We'll write its converse, its inverse, and its contrapositive, and that'll be it. Okay? So, here is our example. So what we're going to do is we're going to let P be the simple statement. I study my homework. And Q be the simple statement. I passed my math class. So what we're going to do for the conditional statement, just the if P then Q, just going to go and write out that sentence. The conditional statement would be if P then Q, which is if P is I study my homework, comma, then you could say, I probably had the word will, I will pass. My math class. That's the, like, not really the original, but I mean, it is the original in a way. It is our conditional statement. So now for the converse, I don't have a way to remember each and every single one and what you do. On your note card for your test, you can write converse. I mean, you could actually write this whole entire thing. That's not you solving a problem. This is you solving a problem. You know what I mean? But you could write swap the antecedent and the consequent. You could write this right here. And, you can do anything like that. The one that I've always been able to remember has been the converse, though. Converse is shoes. And if me and my friend were the same size, like, we could swap shoes. That's that's just like the only way that it's made sense to me, because sometimes swap the antecedent and the consequent, like, I'm gonna be like, hold on, what are those words, but that's what it's saying. It literally takes my shoes and my friend's shoes and we swap them. Okay, so that would be, if I pass my math class, then I will study my homework. Logically, that doesn't even make any sense, but we can go ahead and write that. Okay, after you write the converse, you would write the inverse of the conditional statement. The inverse, the P and the Q remained in the same position, but they had both been negated. So it's like if P then Q, but there's nots with both of them. And it is English, so you do kind of need to make sure that at least it makes some kind of sense. So if not P, then not Q. So if not P, I do not study my homework. If I do not study my homework, comma, then I will not pass my math class. Okay, and then the contrapositive. The contrapositive, okay, I did kind of think about this. I remember being in school, and I was like, it's kind of the most complicated word, right? It has like the most syllables, and so I do the most work. All right, converse, I just swap. Inverse, I just negate. Contrapositive, I swap and I negate. Like, you do both of the works, or both of the work. Okay, so I negate and I switch. So it's if not Q, then not P. If I do not pass my math class, then I will not study my homework. Do they make sense? How to write those sentences? All the different variations. The work that's done with these variations is just as we did. You might not be given no, you would need to be. No, you don't need to be. The tire question? We weren't given the P and Q. We were given like an original, and then we kind of worked with it. That could be very similar to this, but regardless, once you have a P and you have your Q, you should be able to come up with just how the conditional statement would look, the converse of that statement, the inverse of that statement, and the contrapositive of that statement. Okay, so that's it, y'all.